And finally, dear grade 9 students, I'm going to tell you about the scientific notation. That's also a little revision for things you may know previously. What's a scientific notation? A scientific notation is a way of writing numbers in the form of a times 10 to the power n, where a is a decimal number whose integral part is a single digit. So the integral part means the number or the part just before the decimal point. It should be a single digit. For example, 2.34, 1.72, 3. Whatever, and so on. So the integral part should be a single digit that's not equal to 0. 0 point something is refused. Okay? And n, which is the exponent of 10, is an integer. It may be a negative number or it may be a positive number, so it is an integer. Here is an example of scientific notation. 2.34, notice the integral part is 2, just a single digit, times 10 to the power minus 3. That's a scientific notation. 1 can be written as a scientific notation by writing it 1.0 times 10 to the power 0. That's a scientific notation. For example, if I want to write 200 as a scientific notation, I have 200 and I want to write it as a scientific notation. I just write it 2.0 times 10 to the power 2. That's a scientific notation. Now 0.74 times 10 to the power 3 is not a scientific notation. Why? Because its integral part, look at the integral part before the decimal point, it is 0. And that is not accepted. So the integral part is 0. Now let's think a little bit how to change this number into how to write it as a scientific notation without changing its value. Let's think a little bit. How should I move the decimal point? To make this 0.74 as the form of a scientific notation, how should I move the decimal point? Should I move it that way and it will be 7.4, or that way and we will have more and more zeros? So surely we are going to move the decimal point to here. And the answer is going to be, or the number is going to be 7.4. So the number was 0.74 and it becomes 7.4. So let's compare the integral parts. The integral part was 0.74 and it becomes 7.4. The integral part was 0 and it is now 7. It is increased. Because of that, and in order to make equivalence, because I'm not changing the value of the number, I'm just changing the form of writing, the value must stay the same. So because the integral part increased, I have to decrease the exponent of 10. That's what I mean by decreasing. I'm going to put minus. Minus what? How many steps did I move the decimal point? Just one step. So I just moved it one step to here, just like this. So because I just moved one step, I have to subtract 1. I subtract the number of steps I moved the decimal point. And thus the answer is 7.4 times 10 to the power 2. Let's make sure if they both have the same value. 7.4 times 10 to the power 2 is just by moving the decimal like that way, and it is 740. 0.74 times 10 to the power 3 is 1, 2, 3. It's also 740. So notice the value doesn't change. What changes only is the form of writing. So 7.4 times 10 to the power 2 is the scientific notation, while 0.74 times 10 to the power 3 is not a scientific notation, but both of them have the same value if you find their value. So again, if the integral part increases, I have to decrease the exponent. By the same number of steps, I moved the decimal point. Let's have more examples to understand it more. For example, 7.4 times 10 to the power 2 is definitely a scientific notation, while 78.9 times 10 to the power 4 is not, because the integral part, as you see here, which is 78, the integral part is the part before the decimal point, it's 78. It is made of 2 digits, and in the scientific notation it must be just 1 digit. So I'm going to change it to the scientific notation form. So I have to move the decimal point that way or that way. Of course I should move it that way, and it will be 7.89. Now let's compare the integral part. It was 78, it becomes 7. The integral part decreases, so to make equivalence I have to add 1 because I just moved one step for the exponent to make equivalence. So again, if the integral part decreases, the exponent must increase in order to make equivalence and to get the same value when we calculate them. Thus, I will get 7.89 times 10 to the power 5. And let's take a final example. For example, if I have 783.9 times 10 to the power minus 3. And I'm going to change it into the scientific notation form. That's not a scientific notation because I have in the integral part 3 digits. So I just want 1 digit. I have to move the decimal point 1 step and another step. So I'm going to move the decimal point by 2 steps. I will get 7.839 times. What should I do? The integral part was 783 and it becomes 7. So the integral part decreases, then I have to increase the exponent by the same number of steps I moved, so by 2, and thus I'm going to get 7.839 times 10 to the power minus 3, and the plus 2 is minus 1. And that's about scientific notations. Hope you enjoyed them.